We're good. All right, so today we're looking at the series formula for a finite geometric series. When it ends. All right, so we can only do it for 1 and 3. So with a finite geometric series, we're going to use this formula. So the 3 things we need are G sub 1, R, and N. Those are the 3 things we need because that's what we plug into our formula. So on number 1, what is G sub 1? 96. Okay, R is what we're multiplying by. If I look at this, I see that we're dividing by -2. Do y'all see that real easy?
Yeah.
Okay, but I can't write dividing. So dividing by -2 is the same as multiplying by the reciprocal. Very good. So if we divide by -2, we write multiplying by -1/2. That's our common ratio. Now N is the number of terms. Well, I see 6. 6. All right, now we plug into the formula. The sum of the first 6 terms is the first term times 1 minus R to the N. Oh, wait, N is 6. Over 1 minus R. Now, the parentheses are extremely important. I am going to open up my calculator so we can put this in together. All right, you can't just write down my answers. You have to practice with the calculator. Okay? So, if we look at this, this is how it must be entered. We must have big set of parentheses, little set of parentheses, and parentheses around our denominators. You can do it.
Stupid boy. Do it again. Oh crap! I did it. Miss Olivia, can we see the thing where we do this? Because like fraction, like do that, like the numerator.
You can. Sure. Sure.
I got it. Oh, no, so that's a lot. You're going to bend my paper.
-1 traces it. Let me have it right here.
Color is red.
Get God, boy.
Raise all of that to the palette.
Bet you will. You actually stabbed?
I would have played college. I would have played game.
You're freaking.
Yes.
This just made it bleed.
Yes, I'm going to do a little bit, and then I'm going to time in class for y'all to work.
Okay. So I'm going to steal my calculator screen and go put it in our notes so we can make sure that we're making it look correct. All right, so there it is. So this sum is 63. Okay, so you probably want to come back in here and enter this set of parentheses. That set of parentheses is really important. I'll make sure I put that set of parentheses on my on the test. Yeah. All right, number 2 we can't do. It's infinite. All right, number 3. So what do we need? We need the first term. We need the ratio. We need to know how many terms there are. All right, the first term is
1/2.
1/2. The ratio, what are we multiplying by? 2. N. Uh-oh. So, when we don't know, we go back to our old formula so that we can find it out. So our old formula was G sub N equals G sub 1 times R to the n minus 1. So I know the last term is 5/12. The first term was 1/2. The ratio is 2. Let's solve for n. So we have to get it in exponential form, which means we have to move the 1/2. Dividing by 1/2 is like multiplying by 2. I'm about to say, take the log of both sides.
My worst fears.
All right.
Can we not just divide it by 2?
So we get log
Oh, wait, never mind. Yeah.
equals n minus 1 when I pull it out in front times log of 2. So we divide by log of 2.
Just when I thought.
All right. And what do we get?
$3.5. Wait, no, maybe not. Well, yeah.
No, should be a whole number.
Is it log of 2 over log of 2 is 1?
Wait. Log.
No, she's dividing.
I did not give it to you.
To the other
Oh,
side.
okay. I didn't know she was doing all of it.
How the heck did you get 1?
That is
So here we get 10 equals n minus 1. So n is 11. All right, now once again, because we know n has to be a positive whole number, you could do guess and check. All right, now we can find the sum. The sum of the first 11 terms is the first term times 1 minus r to the n over 1 minus r. And you should get 1023.5. All right. So we use this formula when it's a geometric series and it is finite. It's a finite geometric series. That's when we use this formula. All right, all my track people, it's time for you guys to go. Good luck today. And I'm going to keep recording.
Good luck, Dan.
So you can watch this later if you choose to.
I'll do my best.
Okay. Okay, so these examples here are you tries.
Go fast, don't trip.
I'll do my best.
Okay, we're going to save number 4, but I want you to try 1 through 3. Okay, you try 1 through 3. I'll do number 4 with you. All right, so let's talk through these.
I'm doing the homework.
You have to do that in a minute anyway here. Okay, so for number 1.
Wait, was I right? Oh.
No, it was 15. Okay, so for number 1, G1 was given to you, R was given to you, N was given to you. So number 1 was, can I accurately plug into the formula and get the answer? That's what number 1 was testing. So, did you get 1998?
Yes.
0.047. All right. So number 2 took a little more work. Number 2, you had to solve for n. So we had to set up this equation. We had to go back to the old one. So we get 4,782,969 equals 1 times 3 to the n minus 1. So if we divide by 1, it doesn't do anything. So we take the log of both sides. So we get the log of the big number over the log of 3, and that is 14. And so we add 1, we get 15. So now we know we have 15 terms. So because we have 15 terms, 15 gets plugged in for n. So it's 1 times 1 minus 3 to the 15 over 1 minus 3. And so the sum of the first 15 is 7,174,453. Questions?
I realized I forgot a number in the big number.
Oh,
I forgot the 2.
that could throw it off. Yep,
Threw it off by
good bit.
several million.
All right, now, number 3. You may have gotten right here on number 3, and you tried to take the log, and it gave you an error message. Because we cannot take the log of a negative, right?
Yeah.
Yeah? So, we know that a negative raised to an odd power is negative, so this is possible. But to solve it using logarithms, we would do the log of the positive. So you just kind of ignore the negatives and do log of the positive. And so we get n is 12. So we plug in 12. And as soon as I scroll, you can see the answer.
I just couldn't.
Negative 5,460. All right, how are 1 and 2? Good?
Yes. I just calculated that.
No, you're going to need it for number 4.
Oh my gosh, but I don't want it. Didn't realize it.
Add an extra 30 minutes because that's how long it takes to get out of the parking lot now.
I always get stuff stuck in traffic,
Wait, do we speed of a tortoise?
so. No, I don't. Sometimes I run, but then other times, like.
All right, anybody else have any questions about 1, 2, or 3? I see some of you diligently
Copy.
copying. So you go ahead. That way you have something to reference. Sunday night at about 10:30 when you remember you had math homework.
Yep. I'm doing it right now. Sunday night. Wait, what?
Or you could just hang out after the bell rings. Just go ahead and knock it out. Like Preston.
Oh, yeah. Actually, I'd way rather do that than go to SAT tutoring.
Oh. Huh.
But it costs like $100.
Where do you go
So.
for
You better go. You better go.
I go to Dr. Davis.
All right.
He's like a teacher at language.
Rachel David Cruz.
Okay. Now, this one. This one was trickier. Number 4. So, on number 4, you want the sum of the first 7 terms, so you know that's 7. And that's all you know. They didn't give you the first term. They didn't give you the common ratio. But they gave you enough information to find it. They give us the second and the fifth. So, when I go from the second term to the fifth term, I have to multiply by 3 common ratios, don't I? To go from the second to the fifth, I'd have to take that 6 and multiply by 3 common ratios. R times R times R. Do it 3 times. So if I take 6 times the 3 common ratios, that should get me to 162.
Yeah, I was thinking that too.
I knew it. So now we solve for R. So we get R cubed equals 27. Oh, that works out nicely, doesn't it? Because what is R? 3. So now we know R is 3. So if I multiplied the first term by 3 to get 6,
Divided by 1.
divide by 3, and I know my first term is 2. Now I have everything I need. The sum of the first 7 terms is the first term times 1 minus R to the n over 1 minus R.
Wow, totally just.
And we find that the sum of the first 7 terms of this geometric series is 2,186. All right, the back side is classwork / homework, whatever you do not finish. Yes, sir.
I went back to number 2.